mystery of hotter than should be solar winds hitting our Earth has finally been revealed. Earth is, as we know, constantly bombarded by solar winds and cosmic rays, solar winds coming from the center of our solar system. Yet the problem that has been puzzling scientists is why the solar winds that reach our planet are hotter than they should be. And this is defying the laws of physics. It's a mystery. While new research seems to have solved this question, why the particles making up the solar wind plasma from the sun's heliosphere, in other words, these solar winds, take such a long time to cool as they reach our planet. As the sun expels the plasma, laws of physics demand that the wind should cool as it expands through space, because obviously space is supposedly frigid. However, this does not happen to the predicted degree. According to a peer-reviewed study, electron temperatures of solar wind published in Proceedings of National Academy of Sciences, PNAS, University of Wisconsin-Madison physicist offers his explanation for why this discrepancy in solar wind temperature is taking place. Physicist Stas Boldyrev of University of Wisconsin in Madison and his colleagues, his team of Madison physicists Professor Carrie Forrest and Jan Egeldel, sought the answer concerning plasma physics. He says people have been studying the solar wind since its discovery, and very recently, actually, 1959. But there are many important properties of this plasma which are still not well understood, he says. The scientist said that while originally researchers thought solar wind should cool rapidly as it expands away from the sun, satellite measurements proved the opposite, as its temperature was occasionally 10 times larger than expected. In their research, the team used laboratory equipment to study moving plasma to reach the conclusion that the solution is in the electrons that cannot escape the sun's grip. Solar plasma is a mix of negatively charged electrons and positively charged ions, and as the sun is influenced by magnetic fields, that extends into space. The escaping sun's corolla, and doing that, the hot plasma flows through space as solar wind, as we know. The electrons in the plasma are much lighter particles than the ions, generating a speed some 40 times faster. As more negatively charged electrons elude the grasp, the sun takes on a positive charge, in turn rendering it more difficult for electrons to escape its pull, sometimes putting them back into its vicinity. And Stas Boldyrev says such returning electrons are reflected so that they stream away from the sun, but again they cannot escape because of the attractive electric force of the sun. So their destiny is to bounce back and forth, creating a large population of so-called trapped electrons. And mirror machines, when solar wind was first discovered, as we said in 1959, scientists were puzzled over how to confine the plasma, developing mirror machines. These were plasma-filled magnetic field lines shaped as tubes, with the charged particles in the plasma traveling along the lines to reach the bottleneck. The magnetic field lines are pinched, with the pinch acting like a mirror and reflecting particles back into the machine. Boldyrev said some particles can escape, and when they do, they stream along expanding magnetic field lines outside the bottle. Because the physicists want to keep this plasma very hot, they want to figure out how the temperature of the electrons that escape the bottle declines outside this opening. It's very similar to what's happening in the solar wind that expands away from the sun. The team applied the same mirror machine theory to the solar wind, studying differences in the trapped escape particles, and observations showed very hot electrons escaping the bottle disturbed their heat energy slowly to trapped electrons. And they said in the solar wind, the hot electrons stream from the sun to very large distances, losing their energy very slowly and distributing it to the trapped population. It turns out that our results agree very well with measurements of the temperature profile of the sun, the solar wind, and they may explain why the electron temperatures decline with the distance so slowly. The team's findings suggest ways to study solar wind phenomena further in research labs and learn more about solar wind properties in other star systems. Well, okay, that's not really good. That's not very good. If it's hotter than they should be. Anyway, this is one of the theories that they say that this is probably what took place on Mars when it had a very strong direct solar wind corona, a mass ejection, and it could have stripped Mars of its atmosphere. Anyway, this is on Sputnik News. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.